Hello, today I'm going to show you how to use tweepy, the Python library wrapper for the Twitter API, to use the version 2 API, which they recently have added support for, in order to do a full archive search. And so what this means, Twitter is now in the version 2 of the API for academic researchers. They allow you to search the entire archive of tweets and download. I think, let's see, I actually can look it up right here, 10 million tweets per month. And so it's really very generous, really great API and pretty straightforward to use. So this is how you do it. So the first thing, kind of before you're ready for this tutorial, you'll need to apply. So you can do that, if you click this link. I'll make this Jupyter Notebook available. I'll make a link to it in the description. This is where it kind of explains who's eligible for the academic research product track. If you decide that you are eligible, then you apply here. If you think you're not eligible, this tutorial is not for you. You will not have access. It will not work unless you get this access. And so you'll actually have to wait until you get approved. Lately, they've been actually pretty fast on approving. Students in my classes, I think, were approved within a day or two. So once you've done that, once you're approved, come back and watch the rest of the video. So the thing you'll need to do first is create a new app. Let's see, I actually don't remember how you do that. Maybe here, can you create a new one? You might only be able to have one. I think you might be able to only have one for each of your academic projects. So this is, an academic project that I created. Once I'm actually using it for research, I'll have to figure out if I can make a new one. But you create an app, and it should look kind of like this, right? So here's my project app. And what you'll do is click on keys and tokens. What we need for the search API is just a bearer token. And so I'm not positive, it won't say revoke, but it probably says generate once you haven't done it yet. You'll have to click that. I'm not going to regenerate mine because I have it. It will give you a big long string of random letters and numbers. This is it's unique to you, unique to this app, so that Twitter knows who is making the requests. And so basically, you every time you make a request, you pass along this bearer token, and then Twitter knows who you are and sort of who to, quote unquote, charge the request to. So copy that to your clipboard. Twitter will not show it to you ever again. If you lose it, if you accidentally show it to someone or make it public on the internet, you'll need to revoke it and regenerate a new one. So what you'll do after that is create a new document or a new file in the same directory where you save this IPython notebook. So save this notebook, create a new file called twitterauthentication.py, and the entire contents of the file should be this: bearer token equals, and then a string where you replace your bearer token here. So you can, it should just be bearer token underscore token equals, and then your token. And again, like I said, make sure never to share this. If you do, someone will basically have access to your Twitter account. And so if you use Git, for example, add twitterauthentication.py to your gitignore file. Okay. So if it has been successful, then you should be able to run these two. These include the libraries we'll need. If you need to install tweepy, you can do that either through Conda or through pip. If you don't know how to do that, Google it or look it up on YouTube. So those should all import without errors, and then you create a client. And so this is how we create the client. This is where that bearer token comes in. So tweepy sort of handles all of this authentication stuff for us. So we just give it our bearer token, and then it creates this new client object that we're going to be able to interact with. I also put wait on rate limit equals true. This just means it will either, the two options for what tweepy will do, one is it will just stop, give you an exception and stop the code if there's a rate limit. So what a rate limit is, Twitter will either, if you're sort of authorized and ready to make a request, it'll give you back the response. It'll give you back whatever data you asked for. If you've made too many requests lately, and different queries or different API endpoints or APIs have different rate limits. And if you've done too many, then it'll tell you, okay, you've made too many requests, and so tweepy will either stop your code or it will wait until you have more requests that you can make and continue the code. So I think in general it's, tweepy does a pretty decent job of this, and so I just put it to true, to wait and keep writing the code. Okay, so this is a pretty simple example that doesn't get very much data, but hopefully is enough to send you on your way so that you can do more complicated things. The two main ideas that I want to discuss, the first is this idea of additional parameters that you want. By default, if you don't pass any user fields or tweet fields, you'll just get the tweet ID and the tweet text. So that's the default data that will come through. If you want more information, there are these parameters. So I'll talk more about the code in just a second, but here are the parameters. So there's a bunch of these. Let's see. Here we go. The get tweets search all. This link here has a bunch of the fields that are available to you. So click on that and check it out. But I'm getting the created at. This is when it was created. Geographic data, public metrics. So this is stuff like retweets and likes, and then the text itself. And then also I want information about the users. So the username, the metrics about the user, so follower count, things like that, their description and location if they have it. So that's what we're getting. So that's the first idea, is how to get this additional data. The one other thing, if you do want user fields, you also need to add this expansions equals author ID. So this is what I'll show you in just a second, but this is what lets us connect the tweet data to user data. So we get the author ID gets attached to the tweet and that lets us then get the user data or the author data. In order to make sure I didn't get too many, Twitter is huge. You'll learn that as you start doing this. In order to make sure I didn't get too many tweets, I restricted this to literally one day. So I added a start time of January 20th, 2021, and an end time of January 21st, and this is at midnight. So that's what all this means. It actually took me a little bit before I got this format right, but if you wanted to change, this is the hour. Oops, the date should be self-explanatory, but this is the hour, minutes, seconds, and Z is just saying that it's not offset. This is UTC time. Okay, so so that's what we do. The other main, so you need to add user fields, tweet fields. If you want additional data, the other big thing that you'll want to learn that takes some kind of getting used to and figuring out is the query itself. And so there's some good instructions and examples at this link up here. So this is a pretty simple one that is probably pretty similar to what you might want to do. I searched for COVID and hoax, and this is like an attribute of it. So negative means not. This is not a retweet. So original tweets that include COVID, and I believe it's I'm actually not positive. I think it's it's got to be include both COVID and hoax. And you can also restrict the language. So this is really just an example of sort of some of the things you can do. So English language tweets, not retweets that include COVID and hoax on January 20th. The other principle, the other really important, difficult thing to understand is this paginator. There are a few different ways. The big idea is that you will often want to get many tweets, and the maximum you can get in any one request is 500. So I've set the max to 500 here. But that's the most you can get. So anytime you want more than 500 tweets, you'll need to do some sort of pagination. And so what this means is that basically Twitter will give you all of the tweets, but it'll also give you some metadata saying, if you want the next page, here's sort of a token, a key that you can use to get the next page. You can do this manually. You can do this on your own. You can do it with tweepy even. The other option which is a little bit easier, which I'm showing here, is to use tweepy's paginator. So they handle sort of in the background, getting this code, getting the next page, etc., and sort of doing all of it for you. The one thing that tweepy doesn't do, at least as of today, is adding this sleep time. So one of the one thing that's weird about the searching all tweets API is it's the only one on Twitter that has a per second limit. So most of them are per 15 minutes. You can make this many requests. The search all tweets is only one request per second as well. So it's 300 per 15 minutes, I believe, as well as 1 per second. And so I added manually this sleep. So it waits, what that means is it waits 1 second before the code progresses. So we create this hoax tweets list and then append the response to that list. So each time that the paginator makes a request to the Twitter API, we'll take the response and add it to this list. This is a best practice. Indeed, if this was like a real project and I was going to let me run it, make sure it works. If I was going to do a real project, I would actually write this data out to a file so that if I got an error, it wouldn't, just disappear, for example. You may want to, I give a little bit of a description here, but the kind of a pretty simple good practice for this is you sort of write things out to a file, and then every time you run the code, you read in that file, find the last tweet, and start there, right? And then Twitter the API lets you do that. I think it's called let's see, no, I don't remember. It's something like start ID or something like that. You can find this on the API documentation. And so instead of starting at the start time, it will start with the start ID instead. And then you'll just get the tweets you haven't received yet. So that's a good best practice and something. I mean, the reason that you do this is because if you run something long enough, there's almost always going to be some weird network error or something like that, especially if you're running it on a personal computer. And so being able to resume, this is like resume checkpoint, resume where you were is a really important kind of principle. Okay, but I don't do that here, so you'll have to figure out how to do that on your own if you want to do that. The other problem that's confusing is that the data that we get back is nested. It's not just all of this data about a tweet, ready to put into a CSV file. It's kind of a little bit of a messy format for what we want. And so, for example, if we look at hoax tweets 0, so this is the first set of responses, right? In data is where the tweets are. And so this is the second, or the third, I guess, 0 indexed. The third tweet, it tells us the tweet ID and the text. But this is actually an object, and I'll show you. So this is this is where the Twitter or the tweet objects live. The user objects live here. So hoax tweets, so our first response, and then it's in .includes, and then in users it's a dictionary. So this includes could have, you could have place information, you could have, there's kind of all these different things we could have added. We only added users, so that's why it's in the users dictionary, is the only dictionary that's in there, and this is the third entry from there. And it gives just the ID and the name. And the username. Oh, I don't really know what the difference is between those. Okay, so, yeah, that's what it is. So this is like the @ this would be the @ column dub, and this is what they go by. Okay, so what we might wonder is what happened to all the stuff we asked for. I asked for the public metrics and the description and the location, etc. Where is that stuff? Well, these are objects, and so that actually exists inside of these objects. They're attributes of the objects. So for the same person, if we get the description, so this is the same code here, and then .description, this is the description that they've added. So there we go. So the same sort of data, if you wanted to get the tweets, it's in here. So if we wanted like public metrics, that's there, right? And it's a dictionary of all of the metrics about the tweet. Okay, so often what we'll want, and so it's sort of nested and nested and nested, right? There's this list of response objects which each have users and tweets, and then within those, the tweets each have all these attributes, and even within there's this public metrics, which is a dictionary of stuff we might want. So what we want to do often is extract this into a flat file, into a data frame. So this is an example of how to do that. We create a result list and a user dictionary. I'll tell you about why we need that in a second. So what we'll start with, so we're going to loop through each of the response objects, and we're going to take all of the users, extract the information we want from this user sort of data here, and put it into the user dictionary. So for the user dictionary, there's going to be the ID for each user is going to be the key, and then it's going to have a dictionary of information about that user. So their username, their followers, their tweets, a description, and a location. There is additional information that we gathered, but just for example purposes, I assume this is the data we're interested in. And so we create this dictionary first, right? And so we'll have this dictionary of users, their ID, and then information about them. And the reason we need that is because we're going to then attach that information to each tweet. And so while the ordering I think is the same for the users and the tweets, there may be a different number. So let's say we gathered this 1,000 or 500 tweets in this response. Let's say the same person wrote 20 of those tweets. Well, that person only appears once in the user data. And so we'll have fewer users. We couldn't say, for example, that the 150th tweet was written by the 150th user, because there may be discrepancies there. So we create this dictionary so that we can map user data to tweet data. So this is what we're doing here. First, for each tweet, we get the author info from that user dictionary. So the tweet carries with it an author ID. So this is the key. When we went up here, when we added this expansion of author ID, this attaches that author ID to each tweet, and that's what we use as the key to get author information from the user dictionary. So we're going to store that temporarily as author info, and then we put all of this. So we're adding to our results list a dictionary for each tweet. And so that tweet is a dictionary that has the author ID, comes from the tweet, right? The tweet attribute. And then there's a bunch of author information, which comes from the author info dictionary, right? Which we extracted here. So author info username is this author's username, followers, etc. So we extract all of that, and then we do the same, and then I get the tweet information. So the tweet.text, tweet.createlet, and notice for these public metrics, we have to kind of go one level deeper. So first, this is tweet.public metrics, but then we take the retweet count and put it as retweets. Hopefully that's all kind of straightforward. So now we have, at the end of this list of dictionaries that are a dictionary for each tweet in our data set. And so we take that and change it into, this is a format that Pandas expects and allows a list of dictionaries. It knows how to deal with that, and it will change it into a data frame for us. So we run all of that, and here is what our data frame looks like. So it has the author ID, the username, the author's followers, author tweets, author description. How do I scroll over? I think I can't because I'm zoomed in too far. But you get the point. It'll have, there we go. Just do it that way. The text, created out, retweets, replies, likes, and quote count. So we could use this, right? We can use this for analysis. We can do something with this. And it's now in a format that we might expect. So there you go. That is a pretty simple example. The next thing you probably want to do with this is .to CSV, and then give it a name, and that will write this data frame to a file, so that you can save it, and then just load that when you want to do analysis. So there we go. That's that. I also am including at the bottom of this document before tweepy allowed you to use the version 2 APIs. I wrote this code to help you to do it just with the request library. You can see it's much more complicated. We have to do things like create headers and and do this pagination stuff on our own. And so it's much nicer. Be thankful for the tweepy folks who are doing all that work for you. Okay, so that is that. I hope this is helpful.